Question number 66. Limit x tending to pi by 2, gi of 10x into sin x minus 1 is equal to. So first of all, just calculate RHL f of pi by 2 plus, which is equal to limit h tending to 0, f of pi by 2 plus h, which is equal to limit h tending to 0, 10 pi by 2 plus h, that is minus cot h, bracket cosine pi by 2 plus h, that is cos h minus 1, GIF. Limit h tending to 0, which is equal to cos h by sin h, bracket 1 minus cos h. Limit h tending to 0, cos h multiply. If you multiply with 1 plus cos h in numerator and denominator, so you will left with sin h divided by 1 plus cos h, GIF close. So when you substitute h tending to 0 here in denominator, you are left with 2. And in numerator, this is cos h into sin h. So you can write as sin 2h by 2. So which is nearest to 0.00. So which is equal to 0. Now just calculate LHL. In LHL, limit h tending to 0, f of pi by 2 minus h. So just substitute x as pi by 2 minus h. So 10 pi by 2 minus h is cot h multiply sin pi by 2 minus h, that is cos h minus 1. Limit h tending to 0, this is cos h by sin h multiply minus sin square h divided by 1 plus cos h. So you can see easily this is equal to minus 1. So LHL is not equal to RHL. So limit does not exist. So option number 4 is your correct answer. Now move on next question. Question number 67. The equation of curve which passes through pi by 4 comma 1 by root 2 and satisfy the differential equation dy by dx is equal to y times 10x minus y sec x. So just write down dy by dx is equal to y 10x minus y square sec x. Dy by dx minus y 10x is equal to minus y square sec x. Just divide by minus y square. So you are left with minus 1 upon y square dy by dx plus 1 upon y 10x is equal to sec x. So let 1 upon y as t. So differentiation of 1 upon y minus 1 upon y square dy by dx is equal to dt by dx. So your new differential equation is dt by dx plus 10x into t is equal to sec x. This is your linear differential equation. So just calculate IF. That is equal to e to the power 10x dx. So integration of 10x is ln sec x, which is equal to sec x. So now solution of differential equation is t times sec x is equal to sec x into sec x dx whole integration. So t into sec x is equal to sec square x. Integration of sec square x is 10x plus c. Now replace t as 1 upon y. So 1 upon y sec x is equal to 10x plus c. Now question is saying curve is passing through pi by 4 comma 1 by root 2. So just substitute x as pi by 4. So sec pi by 4 is root 2 and 1 upon y, that is also root 2, is equal to 10 pi by 4, that is 1 plus c. So from here you are getting c equal to 1. So your equation is sec x equal to y times 10x plus 1. Now check on your options. Option number 2, sec x is equal to y times 1 plus 10x. This is your correct answer. Now move on next question. Question number 68. Let x bar be the mean of 2n observations x1, x2 up to x2n. Then the mean of the observation xi plus I where I is equal to 1, 2, 3 up to 2n is. So x1 plus x2 plus x3 up to x2n divided by 2n. Now question is asking mean of the new observation, that is xi plus I. So x1 plus 1 plus x2 plus 2 plus x3 plus 3 up to x2n plus 2n divided by 2n. So see x1 plus x2 plus x3 up to x2n, which is equal to x bar into 2n plus 1 plus 2 plus 3 up to 2n. So sum of natural numbers up to 2n, that is equal to n plus 1 divided by 2 whole divided by 2n. So that is equal to x bar plus 2n plus 1 divided by 2. So option number 3 is your correct answer. Now move on next question. Question number 69. Which of the following is true regarding the equation which is given where a, b, c belongs to real number? So just open it. This is 3x square minus 2 times a plus b plus c x plus ab plus bc plus ca, which is equal to 0. So just calculate its discriminant, that is equal to b square minus 4 into a into c, that is ab plus bc plus ca, which is equal to 4 times a square plus b square plus c square plus 2ab, here minus 3ab, so minus ab minus bc minus ca, which is equal to 4 times 1 by 2 a minus b whole square plus b minus c whole square plus c minus a whole square, which is obvious greater than or equal to 0. So discriminant has greater than or equal to 0. Now check on your options. Option number 1, it always has repeating roots, we cannot say. Second, for some values of a, b, c belongs to real, it can have non-real roots. No, it has always real roots. Option number 3, it cannot have repeating roots for any real ABC. It can have. Now last one, it always has real roots. Surely it is correct, because by d greater than or equal to 0, we can say only it has always real roots. So option number 4 is your correct answer. Now move on next question. Question number 70. Let a relation R on the set of natural numbers n be defined as AB belongs to real number if and only if 2a square plus 2b square minus 5ab is equal to 0. For all ab belongs to natural number, then the relation R is. So first of all, we have to check for reflexive relation, that is a comma a belongs to real number. So for reflexive relation, 2a square plus 2a square minus 5a into a, which is equal to minus a square, which is not equal to 0. So given relation is not reflexive relation. Now second, symmetric relation. If your relation is defined for a to b, then your relation should be defined for b to a. So for a to b, it is 2a square plus 2b square minus 5ab is equal to 0. For ab, it is given. So for ba, which is 2b square plus 2a square minus 5ba, which is equal to this thing, so which is also 0. So given relation is symmetric relation. Now third one, which is transitive relation. For transitive relation, AB, if AB and BC, for AB and BC this relation is defined, then this relation should be true for A comma C. So for AB is 2a square plus 2b square minus 5ab is equal to 0, equation number 1. And for BC relation, 2b square plus 2c square minus 5bc is equal to 0, equation number 2. So for AB and for BC, two equation we have, and for relation from A to C, we should require 2a square plus 2c square minus 5ac should be equal to 0. So we have to prove relation. So by using these two equations, we have to eliminate b. So just subtract So you will get 2a square minus 2c square minus 5ab plus 5bc. If you substitute value of b from in any equation, you will not get this relation. So this relation is not transitive as well as. So by checking on your options, option number 1, which is incorrect. Option number 2, not reflexive but symmetric. Yes, this is correct. Third one, equivalence. For equivalence relation, your relation should be reflexive, symmetric and transitive also. So option number 3 also incorrect. Now last one, transitive but not reflexive. This relation is not transitive as well as. So option number 2 is your correct answer.